With us today is Dr. Takrima Sadikot, an associate professor at Washburn University with a PhD in molecular biology and biochemistry. She will go into the science behind UVC light. We will also be joined by Inayat Noormohmad, the president and founder of SARIN Energy, to go in more in depth about the exciting new line of UVC lights that SARIN has brought to market. Without further ado, I would like to hand this over to Dr. Sadikot.
Thank you so much for having me here. As Tucker mentioned, I'm going to talk about the science behind UVC light. So before we go into the specifics of sterilization and disinfection, let's talk a little bit about what UVC light really is. In this schematic, I'm showing you the entire range of the electromagnetic spectrum. Notice here that this is the range of light that is visible to our naked eye, and the ultraviolet radiation is the radiation that falls in the nanometer range below that of the visible spectrum. More specifically, the UV range of the electromagnetic radiation extends from 10 nanometers to 400 nanometers. Now, within this range, you have 4 spectra, which include your UVA, that falls between 315 nanometers to 400 nanometers, UVB, that is 280 to 315, UVC, 200 to 280, and UV vacuum, that's 100 to 200 nanometers. Now, of particular interest to us is UVC, which refers to wavelengths shorter than 280 nanometers. More specifically, so when we talk about wavelengths shorter than 280 nanometers, you're talking about the natural spectrum that the sun's rays produce. When we're talking about the lights that are created for artificially for use in the home and in the environment, those produce and emit a spectrum in the range of which is specific to 254 nanometers. Now, this is important because many biological molecules which are important for function and structure, such as protein, RNA, and DNA, they absorb radiation in the 250 to 280 nanometer range. So how does UVC light work? Most pathogenic diseases are a result of infectious agents that we encounter, such as bacteria, fungi, protozoa, and viruses. These are microorganisms, and I want to go into a little bit more detail about this. When we talk about microorganisms, many of these pathogenic organisms are single-cell organisms compared to us, humans, animals, and plants, which generally tend to be multicellular. We have many, many cells. For example, a human body can have somewhere upwards of 10 trillion cells. So compared to that, microorganisms are very small. Many of these organisms are single-cell structures. So these simple structures are capable of directly and readily absorbing the UVC wavelength. UVC, as I mentioned earlier, affects structures such as DNA, RNA, and proteins. While RNA and protein are both important, the blueprint of any organism, cellular function and development, and also reproduction tends to be the DNA molecule. In this schematic, I'm showing you the structure of the DNA molecule. Typically, when you describe the DNA molecule, you talk about the structure in the form of a step ladder-like structure. Here, we're looking at these 2 outer strands that form the outer sides of the step ladder. And in between these strands, you have these connections, which are the genetic code that is important for structure and function. Notice that between the 2 strands, they are connected to one another with these important codes. There are bonds between these important nucleotide sequences. When UV light penetrates through a cell and falls on a DNA molecule, it disrupts the structure in such a way that it breaks these connections, the interconnections between the 2 strands, and in turn forms a connection that is within the same strand. What we typically call such connections as lesions. These prevent cell survival. These prevent future replication. So in this fashion, your UVC light affects or acts not only as a microorganism static light in the sense that it prevents cell growth, but it also acts as, it also increases the cytotoxicity against these organisms. So it also kills and prevents future replication from happening. Now, since I was talking about the different pathogenic organisms in a way where I had classified fungi, bacteria, and viruses, I'm going to talk to you about certain studies that I have referred here and separated them by each different organism. The first study that I looked at, it had shown that up to 300 seconds of UVC exposures can prevent many different fungal species. I'm not going to list all the fungal species, but it can prevent the growth and the reoccurrence of such fungal species for up to 7 days. This is important. In this particular study, they tested the effect of UVC on the ripening of grapes and also on the spoilage of grapes. So it's important here because it tells you that UVC light may be beneficial to use on food items. Outside of this study, it has also been shown that UVC irradiation is used for, you know, preventing spoilage of breads, grains, cheeses, fruit juices, etc. It has also been shown that UVC functions much better in liquid. So if you're trying to treat juices, it's a much better use to use UVC rather than any other methods. In addition to that, there are very few spore-forming fungi that can survive when you extend the treatment to as little as 500 to 600 seconds of exposure. UVC irradiation can significantly reduce fungal contamination in the air ducts, and this is again very important because it can help individuals who have allergic reactions, who have hypersensitivity to spores, to mold, etc. It can prevent and reduce infections to a great deal. Now, on the three organisms that I'm talking about, fungi, bacteria, and viruses, on the spectrum, fungi are much harder to treat. So as I mentioned in the previous slide, if as little as 300 seconds or 500 to 600 seconds is effective on fungi, you need much less time on bacteria or even on viruses because inherently the structure of the fungi makes it a little more robust. In bacteria, it has been shown that UVC can decrease pathogen load very, very effectively and much better than either UVA and UVB. This difference comes from the penetration of the different lights. UVC has a much higher germicidal capability because of the specific wavelength within which it acts, as I mentioned to you earlier. In addition to that, UVC surface decontamination decreases bacterial contamination, and this is seen across many species, such as Staphylococcus aureus and Enterococcus faecalis. These two organisms in particular, they tend to be highly drug resistant. You might have heard of Staphylococcus aureus in context with methicillin-resistant Staphylococcus aureus, which is notorious for hospital infections, Enterococcus faecalis in terms of vancomycin resistance, again, notorious for hospital infections. It is also effective against bacteria such as E. coli, Clostridium difficile. Now, this last organism that I have on the list, the Clostridium difficile, this can be very, very resistant to normal changes in temperature, normal changes in pH, the use of antibiotics, etc., primarily because it can go into a vegetative state and form spores. So it has also been shown that UVC exposure of greater than 10 minutes can reduce the Clostridium difficile spores. Now, again, this is important because with the increased use of antibiotics in nursing homes, in hospitals, etc., we are seeing a very high increase in the number of antibiotic-resistant pathogens and the number of antibiotic-resistant bacteria. So Clostridium difficile is one of the primary organisms that has been shown to cause gastroenteritis, particularly in senior living facilities, etc. So UVC might be highly beneficial to be used in such environments in order to eradicate spores of antibiotic-resistant bacteria and in order to generally eradicate antibiotic-resistant bacteria. Also, the greater than 90% reduction can be achieved if UVC is used against virulent TB. This is another study that I am showing you here with as little as a 12-second exposure. In case of viruses, it has been shown that UVC can reduce the survival time and rate of vaccinia virus by a factor of more than 10,000. Now, the vaccinia virus is very similar in structure and in function to the smallpox virus. So depending on the kinds of viruses that you're targeting, you might have to change the times and the rates of exposure, but otherwise it's very effective against viruses and enhances the natural biological decay of viruses. UVC exposure is capable of inactivating a number of airborne pathogens such as adenovirus, influenza A, smallpox, and it can reduce more than 96% of the viral load in general, somewhere between 96 to 99%. This is again important because it has been shown that when UVC is used against viral loads that are present in aerosol form, it is much, much more effective than viruses that are on surfaces. Even for viruses that might be attached to surfaces, a range of 10 seconds to somewhere about a couple minutes has been shown to be very effective. Now, sustained use of UVC can create a beneficial effect on overall pathogen reduction and decreasing viral infections. This particular study that I'm referring to has been carried out in a senior living facility where they used UVC for 12 months of the year along with and they compared the time that UVC was used, the 12 months, to the previous 12 months where there was no UVC used, but the other cleaning methods, the other disinfectant methods that they were using was being consistently used. They found that there was somewhere between a 44% to a 46% reduction in the viral infections that happened in that senior living facility. So this is again exciting because it allows us to cater, or it allows the use of UVC in some of the most vulnerable populations, within the human population in general. Overall, viruses exhibit a greater susceptibility to UVC when compared to bacteria, when compared to fungi. However, UVC has been shown to have effective germicidal activity across the board on all these pathogens. Now, another thing that often comes up is when you're talking about the use of UV radiation, there is this big concern for safety. Here in this schematic, what I'm showing you again is the range of the electromagnetic spectrum. Here is your UV electromagnetic spectrum shown here. Typically, the natural source of UV light is the sun. When radiation is emitted from the sun, we have several protective mechanisms. The first protective mechanism that is present is the ozone layer. Through this ozone layer, only about 30 to 40% of UVA and UVB is capable of penetrating, somewhere between 10 to 40%, whereas UVC, the natural UVC, does not penetrate through the ozone layer at all. In addition to that, here at the bottom of this schematic in panel B, I'm showing you the multiple layers of your skin surface. The very top layer of the skin is considered to be the epidermis. This layer is primarily composed of dead cells. Underneath this skin layer, you have the living tissue that is kind of actively live, or these cells are replicating and dividing. As you will notice, UVC is not capable of penetrating beyond this dead tissue at all. So the risk to human skin is minimal. In addition to that, you have melanocytes, or cells within our skin, which produce melanin, and melanin acts as an inherent protective layer to prevent the UVC from penetrating beyond the upper layer of the skin. In addition to this, I don't directly have a quote from this study, but I was recently looking at several other studies. UVC has also been used to treat infectious diseases which are highly antibiotic resistant by directly treating open wounds using UVC. They've carried out studies in animals where they have exposed mice for 24 hours or longer to UVC light, And the effect that they've observed is mostly wrinkling of skin, which is repaired within the next day. So from that standpoint, UVC is pretty safe to use. However, I'm not taking you to mean this as, yes, if you have an open wound, disinfect that with UVC. That's not what I'm trying to say here. The take-home message here is UVC can be effectively used in a room, in an environment, also for surface decontamination with the appropriate precautions in place. So that's what I have. Here are the references I have used in order to create my presentation, and I'm happy to take any questions. So I would just want to add one more thing. When I was talking about the studies that have been done on several animals and mice, that is another important thing, because you can use UVC in a home where you're growing plants and you have animals, and it should be fairly safe to use.
Thank you kindly, Takrima. Appreciate it. My name is, I'm going to start my part of the presentation now. My name is Inayat Noormohmad, and I'm the president and founder of SARIN Energy. And first, again, I want to thank Dr. Sadikot for presenting a very informational sort of presentation on how UVC works and the workings of the chemistry and the biology of that. Thank you again, Dr. Sadikot. So for those of you who have not worked with us, I'm very excited to share a brief history of our company. SARIN Energy is a leading manufacturer of LED lights in the Midwest. We were established in 2011 in Kansas City, focusing on energy savings and customized solutions for our clients in diverse set of industries. We're very proud of the innovative approach that we've employed in meeting our clients' needs and in developing quality products. In 2011, we started in Overland Park, Kansas City, literally out of my garage. We started as an ESCO and started working with our clients who had more and more VE opportunities for us. And that built the foundation for us providing custom engineering solutions and custom fixtures for our clients. It was almost a natural transition for us to go from a local ESCO to a LED manufacturer selling at the national level. We've been very fortunate for our rapid growth, and we currently have offices in Overland Park, Kansas, Houston, Texas, and in Shenzhen, China. Now, as the president of this company, I am very proud and excited to introduce to you our new line of UVC products. Again, keeping in line with our innovative approach. We are pioneering the commercialization of this decade-old technology. Our vision is to position ourselves as knowledge leaders with this technology. And as such, we have invested significant resources in research, product development, and testing. And we are going above and beyond to independently test our products. And we'll talk more about that later. Keeping in focus on quality, our products are manufactured to the highest quality and are in compliance with the FDA guidance. We've also listened to our customers and developed some unique products to meet their needs, as we will sort of find out later in the slides. Now, in terms of our products, we use UVC technology using mercury lamps. As Dr. Sadikot mentioned, UVC lights are very effective in killing pathogens such as bacteria, fungi, and viruses, including previous strands of coronavirus. Now, in particular, we use the wavelength of 254 nanometer, which has been proven quite effective in killing these pathogens. In fact, there are a plethora of studies and white papers which point towards the fact of how effective UVC light is in hospitals, water treatment plants, and nursing homes, etc. And you can see the links to these studies on our website if you'd like to sort of refer to them. Now, in terms of our lamps and the composition of the lamps, we manufacture low pressure UVC lamps with fused quartz glass and mercury amalgam with argon gas. Now, this combination of components creates a highly effective and efficient UVC lamp. There are other sets of combinations which are less efficient and even less effective, and you can see such combinations in some of the cheaper products that are available in the market. We've ensured that our components are of high quality and of the right combination to ensure the most efficient and effective UVC light. For example, when you combine fused quartz glass with mercury amalgam and operate it at low pressure, we create a combination which is excellent for transmission of ultraviolet light. It has high temperature resistance, high thermal shock resistance. It has, high purity in terms of the glass composition and very high chemical strength. So that's just an instance of how we carefully select our components to ensure that we have quality UVC devices. In terms of we skipped over a slide here. There we are, okay. So while UVC lights are much less harmful than UVA and UVB, as Dr. Sadikot pointed out, we wanted to also sort of take into account some precautions and safety measures that we have. And for example, motion sensors, timed functions, remote controls, child safety locks, gravity sensors, and pressure switches. Now these, most of our products have a combination of these safety features to ensure that not only are these products effective, but they're also safe. Now, when considering the key effectiveness measures of UVC light, there are three factors that you may want to consider. One is the power of the lamp. Two is the distance and the area that you're hoping to disinfect, and the time exposure of that particular area. And the effectiveness or the fluence of this UVC light. Scientists use millijoules per centimeter squared or millijoules per meter squared, which is a standard variable across all UVC lights. And I wanted to share this so that you're empowered, and as you do your research, you're able to sort of able to compare lights and its effectiveness. Now, before we get to the point of the presentation, which is the introduction of our UVC products, I wanted to take a few moments and talk about why UVC light and what are the advantages of UVC light. So the UVC technology have specific advantages over other sanitizing and sterilizing options. Advantage number one is UVC light not only disinfects surfaces, it also disinfects the air. So you can imagine airborne pathogens which are out there, which can be easily killed, 99.9% of them, through UVC light. Advantage number two is UVC light is hypoallergenic. It's great for people like me who are allergic to so many chemicals. Advantage number three, UVC devices don't leave any residue and do not cause any cross-contamination. So these are some distinct advantages that UVC has over other sterilization and sanitization techniques that are being used right now. Now, I don't want us to think of UVC light only within the context of COVID-19. So this technology is just as effective for seasonal infections such as flu. And as we become more globalized and we are exposed to new pathogens, I believe this technology will be useful even in those circumstances. So think of this in terms of a long-term investment. So now let's talk about the products themselves. So we have four categories of products that we are sort of wanting to introduce to you. First are the handheld and portable devices. Then we have the area devices, which are meant for small to medium-sized rooms. Then we have large industrial devices, which are meant for medium to large size rooms. And then we have some of our unique patented products that we have developed, again, as we speak to our customers, they've indicated the needs, and then we've sort of taken that and went to our design board and our engineering team to help us design those fixtures for us. So with that, what I would like to do is to have Tucker Hewitt walk through some of these product categories a little bit in more detail, and I will have him take over. Tucker?
So, Inayat, thank you very much. I appreciate it. My name is Tucker Hewitt, and I am the Director of Strategic Accounts for SARIN Energy. So what I wanted to do is just to take a few minutes to introduce you guys to our product line, talk about them individually. But one thing I do want to stress is we're not going to hit the individual features as much as really what I want to do is focus on how you can use these, how you can implement them, and really just a lot of good use cases. So for our first product category, we have the handheld devices. We have the mini, this is going to be something that you can carry around in your pocket. This would be great for disinfecting on the go. It could be doorknobs, business cards, etc. Our portable wand is about 10 inches long. We see these a lot. People can just keep them in their vehicles. It's also something that people keep in their suitcases for when they're traveling. Finally, the large wand. This is about 20 inches long. This is less of a take it around area wand. Where we really see this is it would either stay in a room or stay in a building and would be used to disinfect different surfaces. That could be keyboards, it could be desks in a classroom, it could be airplane seats before or after a flight. So again, I think everyone can realize that there are hundreds or thousands of individual use cases that you guys can use for the wands or the cell phone charger and disinfectant, as well as the sterilization bag. So really what I really also wanted to focus on were using these as amenities. What we really see is, let's say a hotel guest is checking in. They are informed that their room has been sanitized. What the hotel can also provide is kind of a value-added service would be the ability to check out a UVC light for them to spot sanitize their room, or they could rent them out for the duration of their stay. And hey, there's no reason that you can't also offer to sell these for the guests that they're staying. Also, as for the cell phone wireless charger and sterilizer, as well as the sterilization bag, we could see this something that could be in every single doctor's office or reception area. While you are waiting for your doctor or your appointment, you'd be able to offer your customers to sanitize their phone or their belongings while they wait. So there's just a lot of different use cases for these products. Also, beauty salons, we've been getting a lot of requests for info for beauty salons or barbershops. The sterilization bag, it could be used to sterilize combs or scissors before or after appointments, as well as during a haircut. You could offer to sanitize someone's mask or cell phone. The next product category that we have is going to be our area devices. So we have the 55-watt commercial unit, the smaller 38-watt room sterilizer, as well as the 40-watt wall unit. Now, the 55-watt commercial unit, this is going to be our flagship product. So we have been, as a company, been born and bred into the hospitality industry as far as lighting is concerned. So this was something that was top of mind for us when we were developing this product line. The 55-watt commercial unit, this is something that can disinfect let's say the average hotel room is about 225, 250 square feet. This is going to disinfect that within about 10 or 15 minutes. The max range is a lot higher than that, but this is a good representation for hotel rooms. The 38-watt room sterilizer is a smaller unit that you would focus more around the 350 to 400 square foot rooms. The 40-watt wall unit is very interesting. So this is not a permanent fixture that you would need to install on a wall, but this is chain hung. So this does give you the flexibility to move this from room to room. The biggest use cases that we see for this are in food prep and also industrial, kind of more industrial settings. Now, moving on to our next category, these are the big guys. So this is the 110-watt mobile unit, as well as our largest product, the 220-watt mobile unit XL. So, once again, you've heard us talk about that these have been used in hospitals since the 30s. And so this is technology that's been in hospitals forever. This would be the type of unit that you'd be seeing. So this is going to be great for heavy use areas, high germicidal areas, as well as large spaces. So, really every hotel conference room, dining area, or, communal area really could benefit from this. Also, this is mobile, so this is great. You can move this from room to room. Let's say you are sanitizing a communal area for a senior living facility. There's nothing that says that you can't wheel this from that communal area directly to a resident's room and turn that on and sanitize well below 5 minutes to completion. So there's a lot of different opportunities for this. Another big one we see a lot, wrestling mats and locker rooms, especially. We always hear about how common staph is, especially for wrestling. Specifically with the mats themselves. Another big thing that we always get asked about is, okay, so we are thinking about using a mist. We are concerned with residue, but also, let's say in either an outpatient office, they have medical equipment, X-rays, scanners, things like that. They're concerned that the mist would maybe degrade their equipment at a faster rate over time. So, this is something that you would not have to worry about that whatsoever. So this is a very, very unique and neat product line. So our last of these 4 product lines, which are the unique devices, this is something that is it's very neat. So, as we are pioneering the effort to really bring UVC to a more commercial audience. With that, we've had a lot of people reach out with specific applications and to see if we can come up with a solution. A good example of that is we had the Greater Houston Retailer Association and a few other petroleum companies reach out, and they wanted to know, what can we do to sanitize gas pumps and gas pump handles between different customers. So we patented this design. We are the only ones to have this, and we were able to create this product to fit that need, which is, it's a great advantage we have being a manufacturer of lighting, as well as kind of leading the charge to bringing this UVC technology to, a wider audience. So this is something that we're going to be rolling out specifically for gas pumps, but this is something, the more we really thought about this, we kept thinking of more and more applications. So we're also going to be talking to banks as well for drive-up ATMs to sanitize that between customers. So this is something that I'd love to hear your guys' opinion on, where else we could use this and, other types of products. The second picture here you can see is a UVC dropper. So we are coming up with this UVC dropper design, and this is going to be a fixture to sterilize larger rooms, as well as more like a broader use case. This would be great for schools, really anywhere with a drop-in ceiling. What we really like about this dropper, this can be set on a timer, and so if you want to sanitize your room, let's say for 90 minutes at 1 a.m., you can definitely do that. We also have a remote, so you can spot sanitize at any time you want during the day. I think the biggest value that we're going to have with this dropper is we are working with a local controller and technology company. They are going to help us design a system that can record the time the dropper was started sanitizing, as well as the duration of that. This will also include any time you wanted to use the remote sanitize during the day. We'll collect that information, store that locally, so you can see exactly which rooms were sanitized at what time for what duration. And I think this really goes back to the point, and Inayat's going to talk more about this, but our independent testing and ensuring that we give you guys all of the knowledge and info to really make the best use from these products that you can. So this next slide here is going to be the 6 top industries. I really hit on this a lot during the products, but really what we're going to see here is hospitality, senior living, and health. Any of our products are going to be great for that. When it comes to the sterilization bag and the cell phone charger, this is something that you're really going to see and need to utilize more of at the front desk. So you can, sterilize people's belongings coming in, their phone. Also, what would be great for that are the wands as well. So you can sterilize the sign-in sheets, maybe the pens that people are using as well. Food service, our mobile units would be great for that, as well as the wall unit. There will also spot sanitizing with the wands is also extremely beneficial. Office and business is, pretty similar to hospitality. The room sterilizers are going to be great for that. When it comes to keyboards, chairs, and other things like that, you're going to see the wands really come to play. Cosmetic this was definitely an industry that we did not really think about as much, but we've gotten a lot of requests for this. So this sterilization bag is great for that. It's something that you could use to sterilize your beauty supplies, but as well, to offer as an offer to sell to your guys' customers. So yeah, this is just a little bit about our product line, and I really wanted, hopefully you guys are able to see a lot of use cases for this product, and I'd love to hear your guys' thoughts on other applications and other potential products that we could possibly look at. So I really appreciate your time. I'm going to pass this back over to Inayat, and he's going to talk a little bit more about our testing and other types of items that we can provide.
All right. So now, while we may agree that these UVC devices are meant to create a safe and clean environment and are good for public health, I believe another important component in this process is the education and informing of your client and staff or a guest about the efforts that you're undertaking to make their environment safe. So for example, we're working with many of our hospitality partners in developing customized door hangs and other signage to inform the guests of their sterilization efforts, which is again aimed at regaining the trust and confidence of their clients, and hopefully also drive new business. I think this is the other dimension of the UVC use in businesses. Now, with our vision of positioning ourselves as industry knowledge leaders, we've gone above and beyond by independently testing our products. And I wanted to point out that we are not required by any certifying agencies to do these tests. However, we are conducting this test to once again prove that the technology is effective and to validate the quality of our products. Now, hospitals have been using this technology in their ER and surgical rooms for many, many years now. But there was not a good reason to bring that technology out of the hospital arena until recently. And now we have that good reason and opportunity to bring this technology to a more commercial application. And as you will see in the next slides, we are the company that has proven that this technology and our product work and are indeed effective and superior to other ways of sterilizing the product. So let me talk a little bit about our plans for testing. We've completed our phase 1 of testing, which is testing of our commercial lamp and the large wand, and we'll share with you the results of that. Phase 2, which is in the next 2 to 4 weeks, we'll be completing our test for the mobile unit, which is the industrial strength unit. We will then continue on to phase 3 by testing our other UVC products. Then phase 4, we are going to test our products on the previous strands of coronavirus. And then we're not going to stop there. What we are hoping to do is we are also hoping to do an environmental study and a white paper by studying and doing a research on real life sort of environment by putting our equipment in there and testing the effectiveness of that. So we've sort of are working with Microchem Lab. It's out of Austin, Texas. It's a ANAP certified lab that have worked with us to do all the phases of testing. And then let me just start with sharing some of the results. Now, before I go into the results and talk about these, I wanted to just briefly talk about the test itself. The test was a double replicate test, which essentially means that the test was conducted twice on each of the bacteria and viruses. And when we consulted with the lab scientists, they recommended that we test our light on 3 key organisms. And these are the E. coli bacteria, which are commonly found and spread through food and contaminated surfaces. The MS2 bacteriophage, which is a virus which grows on bacteria, and it's a non-envelope virus. And then the third is the staph bacteria, which is commonly found on skin and surfaces. And you know, we heard that nursing homes are particularly vulnerable to these bacteria. So now let's look at the results. So these are the results that are for our 55-watt commercial unit. And if you see the test of that was conducted using our products, more than 99% of these the E. coli and the MS2 and the staph bacteria were eliminated through the use of our products at 2 different distances and 2 different timings. Now, we will have a much more detailed report available of this test after they've completed the peer review of the test and the report, hopefully by next week. Now, looking at the results from the large wand, again, you see the effectiveness of these large wands on these organisms, which are like E. coli, the staph, and the MS2. More than 99% of these pathogens were killed during the test using our product. So it goes to speak volumes in terms of what our products are capable of. And this is, again, a testing, an independent testing that sort of validates our products and the technology. So with that, I wanted to sort of give you perhaps a note that we have a lot more information on our website, details about the spec sheets on these products, as well as other studies that have been conducted on UVC, and hopefully soon the full report of our testing on our website. So hopefully you guys can visit us and take advantage of that information that we're presenting. That kind of concludes our presentation today. I wanted to thank everyone for joining us. I wanted to just introduce the team again. We have Tucker Hewitt out of Kansas City, Blake Holcomb out of Houston office, myself out of Kansas, and my partner out of Houston, Mehdi Tabani. If you have any questions, concerns, ideas, or new products that you want to develop, please reach out to any one of us, and we'd be happy to have a conversation with you. I wanted to sort of quickly do some housekeeping here and ask Robert if there were any questions that we have that we can respond to. We have 8 minutes left, so Robert?
Hey, thank you, Inayat. I have to say it's really exciting being on the forefront of this as more and more people are adopting UVC technology. We did have a few good questions come in, so I just want to address a few of those. And of course, always reach out to us. We're happy to answer further questions. One really good question was, can you go into more depth about the certifications, UL, ETL approval, FDA compliance, all of that?
Sure, sure. So UL and ETL currently do not have a standard for UVC lights. They do, so a lot of the standards are for the components of UL, but not the entire fixture, which we are so used to seeing for our lighting fixture. So I suppose they will still be working on these requirements. I just recently attended a webinar on UL specifically for UVC light, and they've indicated that they currently don't have any such standards. Having said that, I wanted to point out that we've put our 55 watt commercial UVC device through the test of ETL, and so far it has passed with flying colors. There were 3 companies that attempted to do that, and ours was the only one that kind of passed through that. However, ETL not having the standard for these kind of lights, they have not sort of listed us as the you know, within their system. In terms of FDA, FDA has very you know, some specific guidance that they want us to include, and they've made some exceptions in terms of the requirements due to the emergency, COVID emergency that is sort of currently ongoing. And we've spoken to FDA in terms of most of our specific devices, and we've incorporated the guidance that FDA has on these devices into our devices. And we that's why I had mentioned in my earlier comments that all of our products are compliant with the FDA guidance. I hope that's helpful.
No, that's great. Thank you for that. One other question that we've been getting a lot is, how do you know how long to use each of these devices? Because as you know, there's very specific requirements when it comes to effectiveness and time exposure. So if you could explain a little bit why we, yeah,
so absolutely. So if you were to look at some of the detailed specifications on our website for these products, we have indicated to you at what distance and at what time, how much time you would need to disinfect that. Just to be on the safe side, we've been a little conservative in our estimates. So for example, if a room can be easily sterilized in 20 minutes, we would have indicated 30 minutes just to be on the safe side. And as Dr. Sadikot had pointed out, some of these UVC disinfectants is done in a matter of seconds and minutes. So so there is some recommendations that we have in each of our device specifications as to how long and for what distance these devices would work. So hopefully that is helpful.
That's perfect. That's all the questions we have for now. We've answered some other questions that were private. At this time, we're going to close this meeting. So thank you everyone for spending time out of their day to come join us, and we hope you were able to take away something valuable. As always, you're welcome to reach out with any questions, and we are happy to help.